solution, it is the ability of solution which allows electric current through the movement of ions. So this is what conductivity. Okay, and for example, electrolytes, strong electrolytes, and weak electrolytes, strong electrolytes, weak electrolytes, so they are allowing the current through the flow of ions, Here the strong electrolytes have high conductivity, and weak electrolytes have low conductivity. Why? So here the strong electrolytes are having high conductivity, and weak electrolytes are having low conductivity. So there is a reason. So here generally the conductivity depends on various factors. Okay, so one is conductivity depends on so here we discuss only two factors. One is number of ions and mobility of ions. Okay, so the conductivity, it depends on the first factor. What is that? Number of ions. If the number of ions increases, the conductivity also increases. Okay, if more ions are there, they carry more current. Okay, so if number of ions increases, the conductivity also increases. What is the relation? Is directly proportional. Okay, so the number of ions directly proportional to conductivity. So this is the first factor. If number of ions increases, conductivity increases. And second one is mobility of ions. So means the velocity of ions. If the velocity of ions increases, the conductivity also increases. So they are moving fast, so that they carry current, they transfer current very fast. So here if the mobility of ions increases, the conductivity also increases. So here, come to here. In the strong electrolytes, so which are having maximum number of ions. What are strong electrolytes? What is the meaning of strong electrolyte? What are weak electrolytes? How can you define strong electrolyte and weak electrolyte? So if the electrolytes gives maximum number of ions means, for example, HCl. So HCl is a strong electrolyte. It gives how many number of ions? It is a strong electrolyte. It gives maximum number of ions. Maximum means it gives Avogadro number of ions. It means how many ions? Avogadro number of ions. If any electrolyte on decomposition gives Avogadro number of ions, that electrolyte is known as strong electrolyte. Okay, what is strong electrolyte? If any electrolyte gives Avogadro number of ions on decomposition or on hydrolysis, that electrolyte is known as strong electrolyte. Okay, means that electrolyte has maximum number of ions. If the number of ions increases, conductivity also increases. So that strong electrolytes having high conductivity. Why? Due to the presence of maximum number of ions. Clear? And next come to weak electrolytes. What are weak electrolytes? So weak electrolytes are the electrolytes which gives less number of ions. Less number of ions means that those electrolytes are having less number of ions, so that the conductivity also less. Okay, so that here the weak electrolytes are having less number of ions. Less number of ions means having a few number of ions, means that number is below the Avogadro number. So what is Avogadro number? Do you know anyone? Avogadro number. Anyone? Avogadro number. Avogadro number. Intermediate. We have in intermediate. Okay, Avogadro number 6.023 into 10 to the power of 23 number of ions. So maximum number of ions. Okay, here the weak electrolytes are having less number of ions, so that those electrolytes are having less conductivity, low conductivity. So finally, the conductivity depends on the two factors. One is number of ions, and second one is mobility of ions. And another factor is also there, that is valency of ions. Okay, so no need to discuss here. So enough, these two factors are enough to explain the conductivity. Okay, so this is what conductivity. And next to conductivity cell. Conductivity cell. Copied? Okay, what is conductivity cell? Right. So conductivity cell is a instrument. It is a instrument which measures the conductivity of the solution. Conductivity cell. Conductivity cell. What is conductivity cell? It is an instrument. It is an instrument which measures the conductivity of the solution. Which measures the conductivity of the solution. It is an instrument. It is an instrument which measures the conductivity of the solution. So to measure the conductivity, to measure the ability of the solution, conductance ability of the solution, here we have to use one instrument, that is conductivity cell. Okay, by using conductivity cell, we can measure the conductivity of the solution. Conductivity of the solution. And how it is? How the conductivity cell is constructed. Okay, see, here the conductivity cell consists of two platinum electrodes which are coated by platinum black. Okay, so how it is? So it consists of, that conductivity cell consists of two electrodes, two platinum electrodes. What are they? Two platinum electrodes. Two platinum electrodes which are coated by platinum black. Which are coated by platinum black. Coated by platinum black. So platinum black is the material which is coated on the platinum wires. Here electrodes nothing but wires. So they are coated by platinum black. Platinum black powder. Okay, it consists of two platinum electrodes and coated by platinum black, right? And see, here these two electrodes are fixed in a, so these two electrodes are fixed in a small distance. Electrodes are fixed in a small distance. Small distance lo fix chestam anamata. Okay, so see here the conductivity cell. So it's look like a pen lagane untundi, and it consists of two platinum wires. We have the experiment on this. in our labs, in a laboratory, we have this experiment. Okay, we can see there. Okay, so conductivity cell is a instrument. It is a glass instrument which consists of two platinum electrodes, two platinum wires. Okay, and which are coated by platinum black, coated by platinum black. And these two electrodes are fixed in a small distance. కొద్ది distance లో fix చేస్తాం అన్నమాట. And then the conductivity cell, so it is dipped in the solution. It is dipped in the solution, and connected to conductivity meter. So it is connected to conductivity meter. This is what conductivity cell. So conductivity cell is a instrument, or it is a glass electrode conductivity meter. Okay, it is a instrument which measures the conductivity of the solution. Okay, what is conductivity? Already we discussed. And the conductivity depends on number of ions and mobility of ions, and that conductivity can be measured by one instrument, that is conductivity cell. And how it is a glass electrode which consists of two platinum wires and which are coated by platinum black. And then the two electrodes are fixed in a small distance, and then cell is dipped in the solution and connected to the conductivity meter like this. So this is the conductivity meter. And so in a beaker we are taking a solution, and in that solution that conductivity cell is dipped, and this is connected to this conductivity meter. Okay, and here we have one display. In that display we can see the conductivity of the solution. Okay, so that electrode, so like a pen, so when we dip the conductivity cell in the solution, so that electrode is automatically connected to conductivity meter through a wire. Okay, so when that cell is dipped in the solution, so here that conductivity cell reads the conductivity of the solution and display here the conductivity meter. So conductivity meter lo display avutundi. So we can see the conductivity of that solution. Okay, so this is what conductivity cell, right? So this is what conductivity. And next we have two experiments, conductometric titrations and potentiometric titrations. Copied? So conductometric titrations and potentiometric titration, very very important. ఈ రెండిట్లో ఏదో క్వశ్చన్ వస్తుంది. ఓకే, కండక్టోమెట్రిక్ టైట్రేషన్స్. ఫస్ట్ కండక్టోమెట్రిక్ టైట్రేషన్ చూద్దాం. సో వాట్ ఆర్ కండక్టోమెట్రిక్ టైట్రేషన్స్? కండక్టోమెట్రిక్ టైట్రేషన్స్, వెరీ వెరీ ఇంపార్టెంట్. కండక్టోమెట్రిక్ టైట్రేషన్స్. what is titration? In intermediate we done the titrations, volumetric analysis. Okay, so finally what you find in the titration? We find the concentration of unknown solution. Okay, finally we find the concentration of unknown solution. Here also we can find the concentration of unknown solution. There we use an indicator use chestam, methyl orange indicator, phenolphthalein indicator chesara intermediate lo. So by using indicator we can find the end point, by that we can calculate the concentration of unknown solution. But here in the conductometric titration no need to use an indicator. Without indicator we can find the end point, we can find the equivalent point, equivalence point. Okay, equivalent point or end point. So what is end point? End point means, so that end point represents or it shows the completion of the reaction. The reaction is completed. it represents the state of reaction, whether the reaction is completed or not. So when we get color change, by ఎప్పుడు మన color change వస్తుంది, when the reaction is completed, then only we get the end point. End point means color change. And here also the end point can be calculated by conductance values. Conductance values. Okay, so how can you define conductometer titration? See, it is a titration. It is a titration. It is a titration in which equivalence point, and the point where the reaction is completed, equivalence point, the end point under equivalence point or end point. It is a titration in which equivalence point can be determined by the conductance values. Conductance values without using indicator. Okay, so in this titration we are not using the indicator. So without indicator we can find the end point by conductance values. So this is what conductometer titration. Example, strong acid versus strong base. And second one, this is first one, and second one is strong acid versus weak base. Right, strong acid versus strong acid versus weak base. Okay, right. Tell me one example of strong acid, strong base. Strong acid HCl, strong base NaOH. So here only write HCl and here NaOH. And what is strong acid? Same HCl, and weak base means here take NH4OH. Okay, see, so how can you find the conductance values? How can you find the conductance values of HCl and NaOH? Okay, right, let us see. So principle of the titration. So manaku telusu. See, the conductance, first point, conductance of the solution depends on the number of ions and mobility of ions. Okay, the conductance of the solution depends on the number of ions and mobility of ions. For example, if we take a HCl versus sodium hydroxide, what happened when HCl is added to NaOH or NaOH is added to HCl? What happened? A neutralization reaction takes place. Okay, ఏమవుతుంది? A neutralization reaction takes place. Okay, and by that here the sodium chloride and H2O, NaCl and H2O is formed. See, here we are taking this example, isn't it? Strong acid and strong base తీసుకున్నాం. Okay, when strong acid is added to strong base, here salt and water is formed. See, the conductance of HCl solution initially is high. Why? So the HCl solution conductance is high. ఇంతకుముందు చెప్పాను, strong electrolyte. It is a strong electrolyte. It has more number of ions. ఇక్కడ చెప్పాను కదా strong electrolyte, high conductivity, HCl ఇక్కడ. Okay, HCl. So it is a strong electrolyte, means it has Avogadro number of ions. It has Avogadro number of ions or maximum number of ions, so that it has maximum conductance, right? So and one more, here the mobility of H plus ion is also very high. Why? So it has less gram molecular weight, less weight. What is the weight of hydrogen? What is the gram molecular weight of hydrogen atom? 1. So in the periodic table, the lowest weight element, lightweight element is hydrogen. So that the mobility of that hydrogen is high, and HCl is a strong electrolyte. Due to these two reasons, HCl has high conductivity. Clear? HCl has high conductivity. And what happened during titration? During titration, we have to add NaOH solution to HCl. Kada? Then what happened? Ikkadi point right. So due to H plus ions, HCl has high conductivity. Due to H plus ions, HCl has high conductivity. Next, during titration, what we add? During titration, we are adding NaOH solution. అంతేగమ్మా. ఇప్పుడు titration set, what are the requirements for titration? Burette, pipette, and conical flask. Okay, beaker, etc. Right? So here the NaOH solution is taken in the burette, and HCl solution is taken in the conical flask. Okay, so ikkada and so initially ippudu em chestam, initially that HCl solution has maximum conductance due to H plus ions, and gradually what we do, we are adding NaOH solution slowly we are adding NaOH solution from the burette. Okay, while adding NaOH solution, what happened? The number of H plus ions decreases or increases? What it do when the NaOH is added to HCl, what happened? So you see here the mechanism is like this. So here in the HCl solution, H plus ions and Cl minus ions are there. Okay, and in the while adding NaOH, so here Na plus and OH minus ions are added to the HCl solution. Okay, ఇప్పుడు ఏమవుతుంది, these OH minus ions neutralize the H plus ions. So these OH minus ions neutralizes the H plus ions and form the what? Water. What happened when the OH minus when the NaOH is added to HCl, the number of H plus ions gradually what happened? Decreases or increases? ఏమవుతాయి? Decrease అవుతాయి. అది కాదమ్మా, ఇప్పుడు OH మైనస్ ions H plus ions తో రియాక్ట్ అవుతే ఏమవుతాయి? నెంబర్ ఆఫ్ H plus ions ఏమవుతాయి? తగ్గిపోతాయి కదా, డిక్రీజ్ అవుతాయి. సో ఇఫ్ ద నెంబర్ ఆఫ్ H plus ions decreases, what about conductivity? Decreases. కండక్టివిటీ ఏమవుతుంది? డిక్రీజ్ అవుతుంది. ఎందుకంటే నెంబర్ ఆఫ్ H plus ions తగ్గిపోతున్నాయి కాబట్టి ఏమవుతుంది? కండక్టివిటీ ఆల్సో డిక్రీజెస్. ఓకే, సో కాబట్టి డ్యూరింగ్ titration the conductance of solution decreases as the number of H plus ions neutralized by neutralized by NaOH. OH minus ions. Neutralized by OH minus ions. Neutralized by OH minus ions. So during titration, what happens? The conductance of solution decreases as the number of H plus ions neutralized by OH minus ions. Okay, and next two. So the conductance values decreases and reaches to minimum. Okay, and after that, so the number of H plus ions gradually decreases, and after what happened? After completion of H plus ions, what happened? After completion of H plus ions, what happened? The number of OH minus ions increases. The number of OH minus ions increases. If the number of OH minus ions increases, again the conductance will be increases. అర్థమవుతుందమ్మా? ఇప్పుడు ఏమైంది? సోడియం హైడ్రాక్సైడ్ యాడ్ చేస్తున్నాం. యాడ్ చేయడం ద్వారా ఇక్కడ OH మైనస్ ఐన్స్ H ప్లస్ ఐన్స్తో రియాక్ట్ అయ్యి H2O ఫామ్ అవుతుంది. అంటే అలా యాడ్ చేసిన కొద్ది ఏమవుతాయి? నెంబర్ ఆఫ్ H ప్లస్ ఐన్స్ డిక్రీజ్ అవుతాయి. ఎప్పటి వరకు డిక్రీజ్ అవుతాయి? కంప్లీట్ అయిపోయేంత వరకు. ఆఫ్టర్ కంప్లీషన్ అగైన్ వీఆర్ కంటిన్యూస్లీ యాడింగ్ NaOH కదా, కంటిన్యూస్గా NaOH యాడ్ చేస్తూనే ఉన్నాం. అప్పుడేమవుతుంది? ఆఫ్టర్ రీచెస్ టు మినిమం పాయింట్ అగైన్ ద కండక్టెన్స్ వాల్యూస్ gradually increases due to increasing of OH minus ions. Okay, and see, ante ikkada enti, so where the conductance reaches to minimum, that point is known as equivalence point. The point where the conductance reaches to minimum, that point known as equivalence point or end point. ఆ పాయింట్ మనం ఏమంటాం? ఈక్వివాలెన్స్ పాయింట్ అంటాం, లేదా ఎండ్ పాయింట్ అంటాం. ఓకే, సో ఆ పాయింట్ రాయాలి. See, the conductance reaches to minimum at equivalence point. Reaches to minimum at equivalence point. Okay, so this is the principle of the, అలా యాడ్ చేసినప్పుడు ఏమవుతుంది? ఇనిషియల్లీ the conductance is more. While adding NaOH solution, the conductance gradually decreases and reaches to minimum at equivalent point. Okay, that is known as end point. Okay, and there take a volume of NaOH solution and substitute that volume in M1V1 by N1 is equal to M2V2 by N2. ఫార్ములా ఉంది కదా, సెకండ్ ఇయర్లో చేశారు కదా, M1V1 by N1 is equal to M2V2 by N2. ఆ ఫార్ములా సబ్స్టిట్యూట్ చేస్తే వస్తుంది కదా. అక్కడ కలర్ చేంజ్ ఎక్కడైతే వచ్చిందో ఆ ఎండ్ పాయింట్ తీసుకొని సబ్స్టిట్యూట్ చేసామా లేదా? ఇక్కడ కూడా ఎట్ ఈక్వివాలెంట్ పాయింట్ టేక్ దట్ NaOH volume and substitute in the formula. What is that? M1V1 by N1 is equal to M2V2 by N2. Okay, so like that we are getting the equivalence point by conductometric titration without using indicator. ఇక్కడ ఇండికేటర్ ఏమైనా యూజ్ చేసామా? ఎక్కడ కూడా ఇండికేటర్ యూజ్ చేయలేదు. మరి ఎలా ఫైండ్ అవుట్ చేసాము? బై కండక్టెన్స్ వాల్యూస్. ఓకే, ఎలా? ఏ పాయింట్ దగ్గర అయితే కండక్టెన్స్ వాల్యూస్ మినిమం ఉంటుందో ఆ పాయింట్ను మనం ఎండ్ పాయింట్గా తీసుకున్నాం, అంతే. ఓకే, సో ఎక్కడైతే మినిమం ఉంటుందో దట్ గివ్స్ ద ఈక్వివాలెన్స్ పాయింట్. ఓకే, సో ఎట్ దట్ పాయింట్ వీఆర్ టేకింగ్ ద వాల్యూమ్ ఆఫ్ NaOH and substitute in the formula, we are getting the concentration of unknown solution. and this is what principle. And next to required operators, what we required, ఏం కావాలి, required operators ఏం కావాలి దీనికి, see, so we required one is burette, very very important. సో మీరు ప్రాక్టికల్గా రాయొచ్చు, ఇదంతా కూడా ప్రాక్టికల్గా రాయొచ్చు. ఓకే, సో burette, and second one beaker, and third one, so here no need of conical flask. conical flask అవసరం లేదు. జనరల్గా మనం వాల్యూమెట్రిక్ అనాలిసిస్లో conical flask యూజ్ చేస్తాం. హియర్ వీఆర్ యూజింగ్ బీకర్ ఓన్లీ. తెలుసా conical flask అంటే ఎలా ఉంటుందో? ఎలా ఉంటుంది, ఇలా ఇలా ఉంటుంది conical flask. ఓకే, ఇక్కడ ఇది యూజ్ చేయం. ఓకే, ఎందుకు యూజ్ చేయమని నేను ప్రొసీజర్లో చెప్తాను. ఓకే, సో బ్యూరేట్, బీకర్ అండ్ పిపెట్ కూడా అవసరం లేదమ్మా. కండక్టివిటీ సెల్ ఇంతకుముందు చెప్పాను మీకు. కండక్టివిటీ సెల్, దట్ ఈస్ వన్ ఇన్స్ట్రుమెంట్. కండక్టివిటీ సెల్ and conductivity meter, conductometer, okay, so these are the required operators. Okay, so we are required these operators. And next to procedure ఎలా చేయాలి, right? Procedure, first point ఎలా చేయాలి, take a known volume of HCl solution in a beaker. So known volume of HCl solution in a beaker, take known volume like 20 ml or 40 ml in a small beaker. Okay, that is the first step. And second step enti insert conductivity cell in the solution, insert conductivity cell in the solution. Okay, conductivity cell in the solution. And next తర్వాత ఏం చేయాలి, so we are taking the HCl solution in a small beaker like this. So small beaker లో HCl solution తీసుకున్నాం, known volume, we know the volume of that solution, and inside so this is conductivity cell. So insert that conductivity cell, and which is connected to conductivity meter like this. Okay, so a conductivity cell ni mana dip chestam indulo. And next so we are taking here a burette. Okay, burette, right? ee vidhanga burette తీసుకుంటాం, burette stand fix చేస్తాం, and say add NaOH solution slowly from the burette. Yes, from the burette add NaOH solution slowly add చేసుకుంటూ వెళ్ళాలి. And next to measure the conductance values measure the conductance values after each addition of solution, okay, each addition of solution, right? And next final గా సో మెజర్ చేస్తాం. ఇక్కడ ఏం చేస్తున్నాము, ఇక్కడ ఏముంది బ్యూరెట్ లో NaOH solution. We are adding NaOH solution drop by drop into the SL solution. So అంటే ఎంత యాడ్ చేయాలి? ఫర్ ఎగ్జాంపుల్ if we are adding 1 ml for every time 1 ml యాడ్ చేసుకుంటూ వెళ్ళినాం మనం 1 ml యాడ్ చేయాలి and note down the conductance volume. Okay, after that again add 1 ml and note down the conductance values. Like that we are measure the conductance values for every addition of NaOH. Okay, ప్రతి NaOH addition కి మనం ఈ కండక్టెన్స్ వాల్యూస్ మెజర్ చేయాలి. మరి ఎక్కడ ఎండ్ పాయింట్ వస్తుంది? ఎక్కడంటే ఓకే, రికార్డ్ ద రీడింగ్స్ ఆ రీడింగ్స్ రికార్డ్ చేయండి అండ్ ప్లాట్ ఏ గ్రాఫ్ between conductance and volume of NaOH. Okay, so record the readings, so note down the readings and plot a graph between conductance values and volume of NaOH. సో ఇక్కడ మనం ఇక్కడ ఎలా నోట్ చేసుకోవాలి? ఇది నో నీడ్ టు రైట్ దిస్ వన్. సో ఇక్కడ టేబుల్ సీరియల్ నెంబర్ అండ్ హియర్ కండక్టెన్స్ వాల్యూ అండ్ హియర్ వాల్యూమ్. ఫర్ ఎగ్జాంపుల్ ఫస్ట్ వన్ కండక్టెన్స్ వాల్యూస్ ఫర్ ఎగ్జాంపుల్ 100. సో at 0 ml initially we are not adding the NaOH solution, so at that time the conductance value is 100 అనుకోండి. And then second time add 1 ml of NaOH and the conductance values ఏమవుతాయి? By adding 1 ml of NaOH, what happens? The conductance values decreases or increases? Decreases. For example, it is 90. Okay, and then again add 1 ml of NaOH. The conductance values, for example, 80. Like that, record the conductance values in the table and plot a graph between conductance values and volume of NaOH. Okay, so అలా చేసినప్పుడు మీకు ఒకటి కర్వ్ వస్తుంది. ఆ కర్వ్ ఎలా అనేది చెప్తాను. రైట్, సే రైట్, a sharp increase in the conductance value gives the equivalence point. Gives the equivalence point. Okay, so by that we get the equivalence point. For example, a graph draw చేయండి. Take the conductance on y-axis, conductance values on y-axis, and volume of sodium hydroxide on x-axis. Volume of sodium hydroxide and x-axis. Okay, so this point indicates 0. Okay, at 0 ml, 0 volume, what is the conductance value? Maximum or minimum? At 0 volume of sodium hydroxide means at this point the conductance value is maximum. Kabatti, so at this point, for example, this is the conductance value at 0 volume of sodium hydroxide, and add 1 1 ml 1 ml like this. So ఏంటి 1 2 3 4 5 like. Okay, so add 1 ml of NaOH. What is the conductance value? Decreases or increases? Curve ఎలా వస్తుంది? Decreases. కాబట్టి like this, decreases reaches to minimum point, right? And after that, after minimum point, it ఇక్కడ చూడు పోయిందా? సో ఇది ల్యాబ్ కూడా ఉంది, ల్యాబ్ ఎక్స్పెరిమెంట్ కూడా ఉంది. So equivalent point or end point. End point means the point where the reaction is completed, where the neutralization reaction is completed. What is neutralization reaction? Why we call as neutral? It is a neutralization reaction. The reaction takes place between the HCl and NaOH. HCl is acid, NaOH is base. When acid-base titration, when acid is added to base or base is added to acid, those reactions are called neutralization reactions. Okay, it is a neutralization reaction. So what happened in this? When the strong acid is taken in the beaker, it has maximum conductance. Strong acid kabatti it has maximum conductance. While adding NaOH solution, what happened? The conductance gradually decreases and reaches to minimum point. After that, the conductance increases due to the OH minus ions. Okay, so where the conductance increases there, or where the conductance reaches to minimum, there we are taking a end point or equivalence point. Okay, equivalence point గా తీసుకుంటున్నాం దాన్ని, ఆ రెండు పాయింట్ గా తీసుకుంటున్నాం. ఎక్కడైతే కండక్టెన్స్ మినిమంకి వెళ్ళిపోతుందో అక్కడ మనం ఎండ్ పాయింట్ గా తీసుకుంటున్నాం. సో బై టేకింగ్ దట్ వాల్యూ we can calculate the concentration of unknown solution. So here we drawn a graph between ఎలా డ్రా చేసినాం between conductance and volume of NaOH. So conductance value is on y-axis, volume of NaOH on x-axis. So అలా డ్రా చేస్తే ఎలా వస్తుంది? The curve is like a ఎలా వస్తుంది curve? Like a V shape. ఎలా వస్తుంది? Decreases and increases. కాబట్టి ఎలా వస్తుంది? V shape లో వస్తుంది. పోయిందా? వేరే రూమ్ లేదా మరి? రేపు ఇక్కడేనా? Right. So here we have to draw a graph between conductance values and volume of NaOH. So see the conductance values on y-axis. This is y-axis. On this we are taking the conductance values, and next to an x-axis we are taking volume of NaOH. Okay, so at zero volume, that solution has maximum conductance, and by adding sodium hydroxide, gradually the conductance decreases and reaches to minimum point. And then if you add NaOH solution after minimum point, what happened? The conductance again starts to increase like this. So ఈ విధంగా increase అవుతుంది. Okay, so the curve is like a V shape. So this minimum point, so and so draw the equivalent points on x-axis, and at this we have some certain volume, and take that volume as an end point and substitute that volume in the formula M1V1 by N1 is equal to M2V2 by N2. So by that we are getting the end point. So this is what equivalence point or end point. Equivalence point వస్తుంది, right? So this is what a graph, right? So ఇక్కడ ఏం చేస్తున్నాం? This point is extended to y-axis and x-axis. So if you extended to on x-axis, so this point gives the volume of NaOH, isn't it? For example, 0, 1, 2, 3, 4, 5, 6, and at end point, what is the volume of NaOH? At end point, volume of NaOH is what? 6 ml. At 6 ml, we got the end point. Okay, and substitute that 6 ml in the formula, you will get the concentration of unknown solution. Clear? And మీరు అక్కడ ఏం చేశారు? By using indicator, methyl orange indicator or phenolphthalein indicator యూజ్ చేసి కలర్ చేంజ్ ఎక్కడైతే వస్తుందో అక్కడ బ్యూరెట్లో ఎంతైతే వాల్యూమ్ కన్జ్యూమ్ అయిందో దాన్ని తీసుకొని మీరు క్యాలిక్యులేట్ చేశారు. ఇక్కడ మన ఇండికేటర్ యూజ్ చేయకుండా by conductance values we are calculated end point. Okay, end point ని calculate చేసాం. So this is the conductometric titration. And then advantage ఏంటి? Advantages of this conductometric titration. See here, first one is no need of indicator. Okay, and the second one, so used to see it is used to colored solutions. So for colored solution, there is we can't use indicator. For colored solution, we can't use indicators. Colored solution యూజ్ చేస్తే కలర్ చేంజ్ మనం అబ్జర్వ్ చేయలేం కదా. కలర్లెస్ సొల్యూషన్ అయితేనే కలర్ చేంజ్ కనబడుతుంది మనకు. కలర్డ్ సొల్యూషన్స్కి అయితే కనబడదు. కలర్డ్ సొల్యూషన్స్ను మనం we can calculate the concentration of colored solutions also by using conductometer iterations. Okay, it is used to color solution also. And next, obtain accurate values. Obtain accurate values. Accurate గా వస్తాయి. Accurate values అంటే exact values వస్తాయి. Exact values accurate గా వస్తాయి. Okay, so these are the advantages of the conductometric titrations. Okay, so no need of use indicators, that is the first advantage, and it is used to colored solutions also. And third one enti, obtain accurate values. Accurate ga vastayi. Ade manamu indicator use cheste emautundi accurate 10 ml daggara color change avute మనం మాన్యువల్ కాబట్టి అది 12 ml దగ్గర మనం అబ్జర్వ్ చేస్తాం. కలర్ చేంజ్ రాగానే స్టాప్ చేయం కదా బ్యూరెట్, ఇమీడియట్గా మనం స్టాప్ చేయలేం. ఓకే, అంటే ఒక 2-3 ml ఎక్స్ట్రా కన్జ్యూమ్ అవుతుంది. దానివల్ల అక్యురేట్గా కాన్సన్ట్రేషన్ రాకపోవచ్చు. బట్ బై దిస్ వి గెట్ ద అక్యురేట్ వాల్యూస్. ఎందుకంటే వీఆర్ క్యాల్కులేటెడ్ ఎండ్ పాయింట్ వాల్యూస్ ఫ్రమ్ ద గ్రాఫ్. గ్రాఫ్ నుంచి క్యాలిక్యులేట్ చేస్తున్నాం కాబట్టి ఎండ్ పాయింట్ వి గెట్ ద అక్యురేట్ వాల్యూస్. ఓకే, సో దీస్ ఆర్ ది అడ్వాంటేజెస్. అండ్ నెక్స్ట్ అప్లికేషన్స్ ఎక్కడ యూజ్ చేస్తాం? ఎస్, అప్లికేషన్స్ ఆఫ్ కండక్టోమెట్రిక్ టైట్రేషన్స్ వేర్ వి యూజ్. సో యూజ్డ్ ఇన్ అనలైటికల్ కెమిస్ట్రీ, అనాలసిస్, అనలైటికల్ కెమిస్ట్రీలో యూజ్ చేస్తాం. అనలైటికల్ కెమిస్ట్రీ, అనాలసిస్, అనలైటికల్ కెమిస్ట్రీలో యూజ్ చేస్తాం. యూజ్డ్ ఇన్ అనలైటికల్ కెమిస్ట్రీ. ఓకే, and used to know the concentration of unknown solution. Okay, these are the applications of conductometric titration. Okay, so ఇదైనా ఇస్తాడు, లేకపోతే పొటెన్షియోమెట్రిక్ టైట్రేషన్ అయినా ఇస్తాడు, ఏదో ఒకటి ఇస్తాడు.